Hey guys, it's Ms. John. I'm here to bring you our notes video for Unit 1 Notes 2. Today we're going to talk about solving inequalities. So our learning target for today is I can write and solve multi-step inequalities. First, we are going to remind ourselves how we order decimals and set them up on a number line, because we're going to be using number lines today and graphing on number lines. So we just want to kind of refresh our memories on how we put those things up there. I have a set of three numbers here, x, y, and z, and I want to put them on this number line down here. So I have x is 1/4, y is 0.375, and z is negative 0.05. So the first thing I'm going to do is I'm going to figure out what this decimal is in comparison to these two decimals. Well, I know that 1/4 is the same thing as 0.25. So I'm going to use that in comparison with 0.375 and negative 0.05. Now I need to think about how I want to number my number line. I'm going to put my 0, because I have numbers that are positive and I have this one over here that's negative. So I'm going to put 0 kind of in the middle because I need to reference both of it. So one of these middle spots I'm going to make 0. And then I need to count up to 0.4. So I might count 0.1, 0.2, 0.3, 0.4. If I counted 0.05, 0.05, 0.1, 0.15, 0.2, 0.325, 0.3, I don't get quite to the 0.375. So I'm just going to count by 0.1s here, because I need to get all the way up to that 0.375. And then down, I would go negative 0.1 there, because you always have to count by the same interval. You can't switch intervals on throughout the number line. Every interval has to be exactly the same. So now I plot these things. 0.25 is right about here, halfway between the 0.2 and 0.3. That's going to be my x. 0.375 is going to be 3/4 of the way between the 0.3 and 0.4, so right about here, that's my y. And negative 0.05, that's halfway between the 0 and the negative 0.1. So that's my z right there. Take a look at number 2. I have 2.675, 2.5, and 2 2/3. So now all of my numbers are really close to between 2 and 3. So that's how I'm going to number my number line here. Oh, first let's make sure we know these decimals. 2.5 we know is the same thing as 2.5. 2 2/3 is the same thing as 2.6 repeating. If you don't remember that, that repetin is what that line is called. The repetin over the top of a number means that it goes on and on and on forever. 2.6666 and so on. So now on my number line, I needed a number between 2 and 3. And really, I'm only concerned about between 2.5 and 2.675. But I'll just go 2 to 3. I might start down here with 2.0, and then 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7. That's enough to get what I need, because I'm really only going up to the 2.675. Now you could even space these out more, because all three of our numbers, our A, our B, and our C, are going to be between this 2.5 and this 2.7. So we really only needed this tiny little section. So you could have spaced them out even more if you wanted. But I think this will do. I think we'll be able to see. So 2.5 is right here. That 2.5 was my B value. 2.675 is up here. 3/4 of the way between the 2.6 and the 2.7. That's my A. And 2 2/3, 2.66 is going to be just below that, just above the half. That's my C. It's really close together right there in between the 2.5 and the 2.7. Number 3, negative 1 1/3, negative 1.25, and negative 1.38. So let's start by making our decimals. This 1/3 is 0.3 repeating, so negative 1.3 repeating. This negative 1 2/5 is negative 1.4, and that is the negative 1.38. So I'm really between the negative 1.3 and negative 1.4. That's everything that I need here. So I might start my number line at negative 1. And remember, the negative values go to the left. So I'm going to start my negative 1 over here. And then that's going to be negative 1.1, negative 1.2, negative 1.3, negative 1.4, and that's as far as I really need to go, negative 1.5. And we could keep going if we wanted to, but we don't need to because we've shown enough of the number line. That's the other thing. Once you label enough of the intervals so that you know what people are counting by, or you know what you're counting by, that's all you really need. So let's put these up there. X, negative 1.3 repeating. So negative, that's really like negative 1.3333 and so on. So here's the negative 1.30. Here's negative 1.31, 1.32, 1.33, 1.33 repeating is going to be like right in there. That's my X. Y, negative 1.4, is going to be right on this grid line here. That's a Y. And negative 1.38 is really close to that negative 1.4. There's my Z, kind of right in the middle there. One more ordering decimals, so 16 fifths. 16 fifths ended up being 3.2. So I took that. If you're wondering how I'm getting those values, I just take that and divide it in my calculator. 16 divided by 5, hit your equal sign, and you get 3.2. Same thing with this 1/4. I mean, we all know that 1/4 is 0.25, but the 2/9, you could take just this piece, 2 divided by 9, see what you get, and then throw that on behind the decimal point of the 3. So 16 fifths was 3.2, 3 1/4 is the same thing as 3.25, and 3 2/9 happens to be 3.222 repeating. So again, I'm between that 3.2 and 3.3 is really all I need. I might number my number line a little bit more than I did on the other ones. So I'm going to put my 3.2 right here. I'm going to put 3.21, 3.22, 3.23, 3.24, 3.25, and that's really all I need. And then when I put those numbers up there, 3.2, that's my X value, it's right here. 3.25 is my Y value, that's way up here. And 3.2 repeating, here's the 3.2, but 3.2 repeating is going to be a little bit above that. So 3.2 repeating Z, because think of it as 3.222222. There's more than just the 3.20. I need to go a little above. So all I did was space out my intervals. My intervals are really, really small. Only 1/10 are my intervals here. This is 3.20, 3.2, or sorry, 1/100th. That's what my intervals are, 1/100th. All right, so now let's just refresh our memories from yesterday. You don't have this on today's note sheet, but you did write this down on yesterday's note sheet, so you can refer back to that if you need to. But the 4 steps to solving equations, first thing we did was simplify each side by distributing and combining like terms. Then after that, we gathered the variables to one side. Then we canceled the constant using addition or subtraction, and then we canceled the coefficient using multiplication and division. And again, we talked about these a lot yesterday. You wrote them down in your 1-1 notes, so you can refer back to those if you need to. So let's just refresh our memories, do a couple examples. Number 5 is 8a minus 4 times the quantity of negative 5a minus 2. So I need to start by, oh, and that's all equal to 12a. I need to start by distributing the negative 4. Remember that you can think of this as plus negative 4, and that's what's being distributed. So I have 8a, I have plus, because now a negative 4 times a negative 5 is a positive 20a, and then negative 4 times negative 2 is a positive 8, equals 12a. Then I need to combine my like terms, so 8a and 20a is 28a. And then gather my variables to the same side. So subtract that 28a. You could also move the 12a and then move the 8 back. It doesn't matter. Both will give you the same answer. So that's gone. And then I have 8 is equal to negative 16a. Then I need to take and divide it by that coefficient. I don't have a constant to cancel here because I don't have any more constants with my a's, but I do have a coefficient to divide by. So negative 16, divide by that, negative 16. And then I'm reducing this, which ends up being negative 1/2 equals a. You can write it like that, or you can write the a in front Both mean the same thing. Doesn't matter. As long as you give me a reduced fraction or a decimal, I'm fine with that. Number 6, 2/3 x plus 4. Now, 2/3 plus 4, these are both x terms. Oh, and I have no distribution to worry about, so nothing to distribute. I'm going to skip over that, but I do have like terms to combine. This is a coefficient, this is a coefficient. If I add those together, I have 4 and 2/3 x is equal to -20. Now, I can't do a whole lot with the 4 and 2/3. You could just divide by 4 and 2/3 in your calculator, but it's really messy to type in. So I'm going to turn this into an improper fraction instead. I'm going to multiply by the bottom and add the top. So that's 4 times 3, which is 12. 12 plus 2 is 13, 14. So 14 over 3 times x is equal to -20. Then to get rid of this, I have no constants, so I don't need to worry about the constants, but I do need to get rid of the 14 over 3. So I'm going to multiply by 3 over 14. That's called the reciprocal, in case you forgot that term. Reciprocal. Okay, that's when you flip the fraction. So flipping the fraction gives me the reciprocal, and when I multiply by the reciprocal, I have 3 times 14 on the top, 14 times 3 on the bottom, and they cancel each other, which gives me just x. But I multiplied by that on the left, so I need to multiply by that on the right as well. So over here, I have -20 times 3, which is -60, and then divide by the 14. -60 divided by 14 is -4.286. 4.286. Now you got a decimal that went on and on and on there. I just went to the 4th place and rounded to the 3rd. Technically, I guess that makes this an approximately equal to, but either way is just fine. Okay, now let's refresh our memories on inequality symbols. I'm sure you've seen these inequality symbols before, but we're just going to talk through them. The first symbol is less than. That alligator is pointing away from the first number. So that's less than, or meaning not as much as or fewer than. The next symbol is greater than, which is also. The next symbol is less than or equal to, which is at most or no more than. And the last one is greater than or, did I say that wrong? Less than or equal to. This one is greater than or equal to. Sorry if I said that backwards. This is less than or equal to. Here's greater than or equal to. And that one is no less than or at least. Now remember, part of these videos is you can pause them at any time. So if I went through those fast and you're still writing, feel free to pause it now and take a minute to finish writing before we move on to the next example. The last thing on the bottom of your front page, number 2, reverse the inequality symbol. You need to flip the sign when you multiply or divide by a negative. Okay, reverse the inequality symbol when you multiply or divide by a negative. So that's one thing that you can solve in equations. Okay, so let's take a look at number 7. Number 7 says -4 times the quantity 5w minus 8 is greater than 52. So I distribute that first. That gives me -20w plus 40 is greater than 52. Now I have a constant to get rid of, so I'm going to subtract that 40. And I get -20w is greater than 12. Oh, haha, that's because I multiplied wrong. This is not 40. What am I doing? This is 32. I was thinking 5. There we go. I knew something wasn't right. Okay, let's try that again. So 52 minus 32, sorry about that, is actually 20. There we go. Divide by the -20. Now, take a look. I am dividing by a negative. Dun, 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 there it is. So this symbol is now going to become a less than symbol because I need to reverse the direction of the inequality. So my -20 over -20 goes away. I'm left with w. 20 divided by -20 is actually -1. Okay. Now let's talk about how we graph these. These symbols This less than symbol is going to be an open circle at -1. Now, it's always good to have 0 as a reference on your number line somewhere. It doesn't have to be in the middle, but it's good to have 0 on there to help you reference just kind of what's happening and what you're counting by. So you always need to tell me what you're counting by. I'm going to put my 0 here, and then I'm going to say -1, -2, -3, here's 1, here's 2, and so on. So notice that my intervals are all counting by the same amount. I went up by 1 for each line. Okay, I didn't change what I'm counting by anywhere on the number line. I counted by the same thing every time. So less than is an open circle, and numbers that are less than -1 shade to the left. So that's what you have to ask yourself is where are the numbers that are less than -1? So anything in this yellow shaded region is a solution to that inequality. Okay. By the way, I didn't put this on the last screen, but if you wanted to, on the front of your page, put what circles go with what, these two circles are open. When you get that less than or equal to and greater than or equal to, those circles get filled in. So you don't have anywhere on the front of your sheet to put that, but you can just write it off to the side if it'll help you remember what circles to put on the number lines. Okay, let's take a look at the next one. 13 minus 4k is less than or equal to 27. So I need to get rid of that constant. So this constant of 13 needs to be subtracted. Oh, that's hard to see. Sorry. I'll go back to purple. It's a little bit better. So subtract your 13. That's going to go away. The negative is still there. Be very careful with that. So negative 4k is less than or equal to 27 minus 13, which is 14. And then divide by the -4. Take a look at what you're dividing by. You're dividing by a negative. So again, this is going to flip. So instead of less than or equal to, now it's greater than or equal to. This is gone. I have k, which is what I want, and 14 divided by -4, -3.5. So now, on my number line, I need to go down to -3.5, which is to the left of 0. So if I start my 0 way up here, and then I go -1, -2, -3, -4, I can get my -3.5 right there. This is a closed circle because it has that less than or equal to, or in this case now greater than or equal to line underneath. So I'm shading greater than or equal to. Numbers that are greater than -3.5 shade to the right. So all the way up here. If you're using just pencil for these, which most of you probably are, some people like to draw their arrow up a little bit from the number line and shade up there so they can see it a little better. It's hard to do pencil over the black number line and see which direction you're going. That's why I like to do the squiggly, because then the squiggly can kind of darken that in a little more. It's up to you. Somehow just make it obvious which direction you're going. And always put that arrow on the end as well. Number 9, 9x plus 5 is greater than 4x. No distribution here, but I do have like terms to combine. I'm going to take that 4x that's on the right, and I'm going to just subtract it to the left. So I have 9x minus 4x, which is 5x, plus 5 is greater than 15. Then I have a constant to get rid of. So 5x is greater than 10. And, oops, divide by 5, I already had the answer in my head. 10 divided by 5 gives me 2. In this case, I divided by something positive, so I don't need to flip my sign. It stays greater than, and 10 divided by 5 is 2. So x is greater than 2 is what I'm looking at there. If I number my number line, I'll do 0, 1, 2, 3, 4, just to make it really clear what we're numbering by. 2 is right here. That's an open circle. There's no equal to line underneath, so open circle. Numbers greater than 2 go to the right. 3 is greater than 2. That's how you can kind of test that theory. And shade to the right. One more practice of these. I have b divided by -3 plus 5 is less than 10. Now, I have no distribution here. A lot of people automatically look at this b divided by -3 and want to get rid of that -3. You can't do that. That -3 is only affecting the b. The first thing I have to get rid of is this. So I'm going to subtract, that's my constant. I'm going to subtract my constant to move it to the other side. That's going to cancel that. I have b over -3, and 10 minus 5 is 5. Now you can get rid of the division of -3 by multiplying by -3. That makes those go away, and I have b is less than, oh, that should be a negative. Didn't write that in, sorry. b 5 times -3, which is -15. Now, ooh, one thing I forgot to check. Hello, I multiplied by a negative. That means this needs to actually be flipped. Sorry about that. Flip your inequality. So this is going to be greater than -15. B is greater than -15. Now, -15, I have to count down kind of far from 0. So I'm just going to count by 5s instead of 1s. So if that's my 0, this is my -5. This is my -10. This is my -15. And then I'll put my, I can just put one more just for good measure. I'll put my circle. It's an open circle here. Numbers greater than -15 shade to the right. All right, 3 word problems and then we are all set for today. Number 11, enemies 250 for each ride. You go to the park with 60 bucks, write and solve an inequality that represents the possible number of rides you can go on. So, first thing I always have to do is label a variable. Figure out what it is I'm trying to find. So I'm trying to find the possible number of rides. That means R is going to be my number of rides. Now I ask myself what's happening to those rides. Well, I know that each ride is 250, so I have 250 times each R. I also know that the park is charging $15 to get in, so that's another piece that I'm spending. So plus 15, this is what I'm spending. Now on the other side, what I have is 60 bucks. Then I got to fill in the middle. Notice that it says write and solve an inequality, not an equation. So I have an inequality symbol that's going to go in here. And what is that inequality symbol going to be? So I need to spend less than what I have. You can't spend more than 60 bucks. You could spend exactly 60 bucks, so I could be less than or equal to there. Then I'm going to solve it. So here's my inequality. Now I need to solve it. Subtract the 15. I have 250R is less than or equal to 60 minus 15 is 45. And then divide by the 250, or the 2.5. I'm dividing by positive, so I don't need to flip the symbol. 45 divided by 2.5, or 2.5, is 18. So at most, 18 rides. That's what I'm looking at there. Let's take a look at number 12. You have $18.50 to spend on a pizza. It costs $14 plus 75 cents for each topping, tax included. Write and solve an inequality to find the maximum number of toppings the pizza can have. So I'm going to say T is my number of toppings. I feel like that background is hard to see. I'm going to fix it because I feel like it might be hard for you to see. How about let's do this? Sorry if that first background was hard for you to see. So T is my number of toppings. Be careful when you use T. Some people just like to stick with X because you can see it better. I like to put a little tail on my T so that you can tell it's not a plus sign, because sometimes T's and plus signs look the same. Okay, so what's happening to the toppings? I know that the toppings are 75 cents each, so 0.75 times my number of toppings. I also know that I need to spend a base price, basically, for like a cheese pizza of $14. So I'm going to add 14 to that. I know that I have $18.50 to spend. That's the other side. So here's what I'm spending. Here's what I have. What is my inequality symbol? I can't spend more than what I have, so what I spend has to be less than. It could go all the way up to exactly $18.50, so I can put the equal sign on, but it can't go over. Now I solve it. Subtract 14, no distribution, no like terms, no variables on the other side. Only variables on one, which is good. That's 14.0, so be careful with that. So 0.75t is less than or equal to 4.5, and then divide by the 0.75, and that goes away. I don't need to flip my symbol because I'm dividing by a positive, so I have t is less than or equal to 6, which means I can have at most 6 toppings on my pizza. Last question. Park colleges cost $15 to attend. Oh, there's that yucky background again. Sorry. We'll fix it. No, this. And how about that? There we go. For Park College's basketball games, it costs $15 to attend. A season pass costs $170. At most, how many games could you attend at the $15 price before spending more than the cost of a season pass? So this is that common question that you have for a lot of things. Zoo passes, Valley Fair passes, ski passes at Buck Hill. Will you go enough? Are you going to attend the game enough? So I know I'm looking at the number of games. So at most, how many games? That's what I need. So I'm going to say G is the number of games. And I want to compare. I want to compare the price of paying each time to the season pass. Those are the two things I'm looking at. Well, I know the season pass side. Season pass side is 170 bucks. If I pay for each game, I'm paying $15 for each game. Now it says, at most, how many games could you attend before spending more? So you want this to be less than the cost of the season pass. That's what you're looking for, is how many games can you go to before spending more than the season pass. So let's divide by the 15 there and see what we get. I have no other fees here, nothing else that says it's charging you for. So I do G, so that's not equal to, just less than. Less than. And then 170 divided by 15 is 11.3. Now, you can't attend 0.3 of a game. They're not going to charge you for that. They're going to charge you for a whole game. So I can't count that as 12 games. I have to only count that as 11 games. Basically, I'm cutting this piece off because I can't pay for only 0.3 of a game and then say, oh, I'm going to leave after a third of the game is over. That's not how it works. So I'm just looking at the whole number of games. That's the max number. So at most, 11 games. All right, that takes us to the end of our notes. Don't forget that you can go back and rewatch and look again and pause and anything that you need to do to get all of the notes that you needed for this lesson video. Thanks for listening, and I will see you next time.